All right, let's dive into something that's honestly a huge deal in tech right now. How do you teach a machine to actually get what we're saying? To really understand our language. We're going to go on this little journey, starting with just a bunch of words and ending up somewhere pretty cool, uncovering opinions, context, and yeah, even hidden themes.
I mean, it really all comes down to this one question, right? When you type something into your phone or computer, how does it get past just the letters and the words to figure out what you really mean? It's like this giant, complex puzzle. And, well, over the next few minutes, we're going to put the pieces together. Okay, let's look at a super simple example to get started. On one hand, you have a review like amazing phone. For a machine, that's a piece of cake, right? The word amazing is a giant flashing green light. But then, look at the other side. Pictures are sharp, but night photos are noisy. That's got good and bad stuff in it. That kind of nuance, that's how we actually talk, and that's the real challenge we've got to crack.
So, where do you even begin with a problem like that? Well, you start with the absolute basics. Before a machine can ever hope to understand the meaning, it has to understand the structure. It's got to find the sentence's secret blueprint.
You see, a sentence isn't just a jumbled bag of words. Nope. The order, the way words connect to each other, that's everything. So the machine's very first job is to draw a map, a grammatical map, figuring out how every single word links up with all the others.
To make this feel a bit more real, let's actually follow one sentence through this entire process. Our little test subject for today is, Python is really amazing. So let's see how a machine tears this thing apart. For every single word, the machine does this little three-step dance. First, it's step one. It figures out the part of speech. Is it a noun, a verb, an adjective? Then, step two, it determines the word's actual job in the sentence. They call this its dependency. And finally, step three, it finds the head word, which is just the main word it's connected.
And it doesn't just do this in its head. It uses these specific labels for these jobs. For example, it looks at the word Python and slaps the tag on it, NSUB. That's just a fancy way of saying nominal subject. It's not a guess. It's a super precise label that tells the system, hey, Python is the main thing being talked about.
And boom, here's the final blueprint. Just look at this thing. Every single word is tagged, it's linked. You can see clear as day that Python is the subject of is. You can see that is the root, like the absolute backbone of the whole sentence. And you can see how amazing describes Python through that verb is, while really is just there to beef up the word amazing. This is the map we were talking about.
Okay, so we've got the blueprint. It's a bit nerdy, but you might be thinking, so what? What's the point of all this? Well, here comes the payoff. Now that we have this map, we can use it to automatically pluck out the exact phrases that are expressing an opinion. This is really where the magic starts to happen. See, all that grammar stuff isn't just some boring homework assignment for the computer. It's an incredibly powerful tool that lets the machine laser focus on the bits of the sentence that really matter when you're trying to figure out if something is positive or negative.
And how does it do that? Well, it basically goes pattern hunting. It's trained to look for specific grammatical setups. For instance, it's looking for that Ahmad pattern that's just an adjective right next to a noun, like in deep learning. And it's also on the lookout for the acomp pattern, which is exactly what we saw in our sentence, an adjective describing the subject through a verb, like in Python is amazing.
And the result of all this pattern hunting is pretty awesome. The system takes messy, everyday language and turns it into clean, organized, structured data. It's not a bag of words anymore. Now it's a network of real connections. For our sentence, it now knows, for a fact, that amazing is directly connected to Python.
All right, so we've successfully pulled out the core opinions. The next logical step is pretty obvious, right? Are they good opinions or bad opinions? It's time to put them on the sentiment scoreboard and give them a grade. Now, there are a couple of main ways to do this. I like to think of it as the dictionary versus the professor. The dictionary method, using a tool like Vader, is simple and fast. It literally just looks up words in a big list that has pre-assigned scores. But the professor method, using a heavy hitter like Spurt, is way more sophisticated. It doesn't just look up individual words, it actually understands the meaning of the whole phrase.
So what the heck is SBIRT? It stands for Sentence BIRT, and it's a model that is an absolute genius at one thing, taking a phrase and converting it into a long list of numbers, what we call a vector. And that string of numbers isn't random, it captures the actual meaning of the phrase. This is huge, because it lets us compare phrases based on what they mean, not just what words are in them.
And what you get at the end is a score, just like this one. It's called a compound score,
which is really just a single number that sums up the overall feeling. The scale is pretty simple. It goes from -1 for, super negative, all the way up to +1 for super positive. So a score like plus 0.85, yeah, that's telling us this phrase is very, very positive.
But just having a score isn't always the full story. And this, right here, is where the professor, SBRT, really earns its reputation. Because if you want to truly, deeply understand language, you have to get one thing straight. Context is everything.
Okay, let's just take the word large. In the world of fashion, a large dress is totally neutral. It's just a size, right? No big deal.
But now, let's switch contexts. Let's go to AI. A large language model is suddenly a good thing. It's positive. It means it's powerful, it's capable, it's top of the line.
And okay, one more shift. Let's go to medicine. A large tumor is, without a doubt, very, very negative. See? The exact same word, large, but 3 completely different feelings behind it. Only a model that gets context can nail this every time.
Okay, so let's recap. We can break down a sentence's grammar, we can pull out opinions, and we can score them while understanding context. So what's the grand finale? What's the big payoff? It's being able to zoom all the way out from these tiny little opinions and finally see the big picture, to find the hidden themes running through the whole conversation.
When you do this for hundreds or even thousands of sentences, you can use these smart algorithms to automatically group similar opinion phrases together. And what's so cool is what you end up with. You can see the main topics people are talking about just pop right out. Things like AI innovations, AI risks, and the basic concepts of NLP itself.
And what's even better is we can actually peek inside these groups. The AI innovations cluster, it's full of positive stuff like deep learning and generative AI. Then you look at the AI risks cluster, and that's where you find all the concerns, model collapse, data privacy risk. We've officially gone from a giant mess of text to real, structured, thematic insights.
So there you have it. We've gone the whole 9 yards, from decoding a sentence's blueprint, to scoring opinions with context, and finally to uncovering the big themes. Machines are, genuinely, learning to read between the lines. Which really only leaves one big question, doesn't it? Now that they can do that, what should we ask them to read next?